Greetings everybody. I wanted to show you a question from my math lab about Chebyshev's inequality. Okay, and that question I had in mind is this one. It's given to me that the mean score on a statistics test is 64 points. The standard deviation is 5 points. And it says apply Chebyshev's theorem to the data using k is equal to 2. Okay, so let's look at what Chebyshev's theorem says in the first place. We can make some predictions about the data set, even though it's not given to me what the individual scores are, like nowhere in this question. It's just that somebody took the scores and found the mean and found the standard deviation. That's all I have, but I can make some predictions. And Chebyshev's inequality says at least 1 minus 1 over k squared times 100% of the data will be within k standard deviations of the mean. See how this k occurs twice, once in a calculation and once to describe how many standard deviations from the mean the data is going to be. Okay, now in this question it was given that k is 2. So I want to translate this statement, but I'm going to let the k be 2 according to the instructions and according to what Chebyshev's inequality says. Alright, so to translate this using k is equal to 2, remember this question did say let k be 2. Alright, so it would say at least 1 minus 1 over 2 squared times 100% of the data are within 2 standard deviations of the mean. Now to calculate a little bit further, 1 minus 1 over 2 squared, well, 1 over 2 squared is 1/4. This is 3/4, which is 0.75 times 100%. Get 75%. So then the statement says at least 75% of the data are within 2 standard deviations of the mean. Okay, so 75% of the data is within 2 standard deviations of the mean. That's the first part of the question, at least 75% of the exam scores. Alright, so I got that. What about these other numbers? Well, what would it look like to be within 2 standard deviations of the mean? Okay. Well, the mean was 64 and the standard deviation was 5. Okay, so I'm going to say like 64, that's kind of the middle of the data. And the standard deviation was 5. So if I go 2 standard deviations up, that would be 10 points up to 74. Okay, and if I go 2 standard deviations down, that would be 10 points down. That would take me to 54. Okay, so we can make this statement a little more precise. We can say at least 75% of the data being within 2 standard deviations of the mean means that it's between 54 and 74. Okay, at least 75% of the exam scores are between 54 and 74, and I don't even have to see the data to know that. Like, remember, it doesn't say here are the individual exam scores. Nowhere in here does it say that. But I can make that prediction based on Chebyshev's theorem. Okay, so that's why when I put the answer in here, I said 75% of the exam scores fall between 54 and 74, because 54 to 74 would be 2 standard deviations down and 2 standard deviations up from the mean. And that's where we know 75% of the scores are going to be, even without seeing what they are.